Hello, everybody. I'm Jeremy Williams, and I'm the Ag and Natural Resources Agent here in Harlan County, Kentucky. And today we're going to talk a little bit about garden drip irrigation. I do want to thank Bonnie Sigmund, the horticulture agent in Laurel County, Kentucky, for allowing us to use her PowerPoint presentation. So what I'm going to do is I'm going to go ahead and share my screen and switch over. Give me just 1 second. Okay, that should take care of it there. Hope everybody's having a great day, and we're getting into the garden season. Although it may be a little bit wet right now, there's a possibility of things drying up. So let's start with the basics. So how much water does a garden need? Well, in general, soils need about 1 inch of water a week in order to provide adequate moisture for plant growth. But you know, there's several different conversions that you can look at. Because everything's a little bit different. For instance, 1 square foot is about 144 inches. Is 144 inches. So if you cover that with 1 inch of water, you're going to need about 144 cubic inches. So basically, doing some math, you're going to need about 0.62 gallons of water for that plant per week to get a 1 inch of rain per week, or 1 inch of water per week. You're going to need about 0.62 inches of water. So another example would be, say, a 4 by 8 raised bed garden, which roughly equals 32 square foot. And so that shows that you're going to need about 20 gallons of water per week. And so definitely you're going to need some water. And other factors that determine watering requirements are going to be the soil structure, the texture, type of plants in the garden. So we'll talk a little bit about soil structure. As you can see here, you've got the soil pyramid, and we got 3 different types of soils. We got sandy, loam, and clay soils. Soil texture is determined by the proportion of sand, silt, and clays that are in that soil. It's important to know what type of soil you're actually irrigating. So why is that important? Different types of soil require different watering requirements. For instance, sandy soils are made up of large particles, and because the large particles, the space between the particles is large, and the water can move rapidly through those soils. I know if you're gardening in sandy soil, it doesn't take long for it to dry out. And 1 inch of water will move through or wet approximately 12 inches of sandy soil. Thus, the sandy soil, they have a low water holding capacity, and because of those large particles and the spaces between the particles. Soils containing loam and a combination of silts, clay, and sand have smaller particles. These soils have smaller spaces between particles and will retain moderate amounts of water. As the soil texture gets finer, in other words, has smaller particles, its capacity to retain moisture increases, and 1 inch of water will wet less soil. So approximately 6 to 10 inches of loamy soil. Because clays are made up of very fine particles, they're capable of retaining the greatest amount of water. 1 inch of water will wet approximately 4 to 8 inches clay soil. I remember my uncle one time had a pond that continued to leak, and he was able to put clay in the bottom of it to stop the leak, because the particles are so small, they were able to retain the water. So if you've got some clay subsoil in your garden, you may notice even that you'll have some water standing around in those areas because the particles are so small. So what have we learned so far? If you have sandy soil, you may have to water more often because the soil tends to hold less water and dry out faster. On the other hand, if you have clay soil and a deep-rooted plant, you may have to apply more water less frequent, in less frequent intervals. This type of application is necessary to wet the soil deeply, but because of the soil's water holding capacity, you may actually water less. In short, every garden is different, and you'll ultimately have to do some experimenting to make sure what your best watering regimen for your garden is. So, soil structure. Talking about the arrangement of soil particles and organic matter. Now, we talked about organic matter the other night when we discussed the composting and also the garden BMPs. Soil structure can be improved or degraded by the soil management. We talked about that with the composting. We know what happens when wet soil is worked in early spring. Basically, bricks are made. You know, it's going to harden up. When you go in there and till that up or plow that, you could even possibly hurt the soil structure by creating a hard pan. So a granular or crumb structure is desirable in topsoils. The thick, the sticky gummy byproduct of residue decomposition hold the soil particles together in clumps or aggregates and forms the basis of good soil structure. The introduction of organic material or the compost, like we talked about, into soils actually increases the soil's potential to produce plant growth because it creates space between the soil particles. Clays made up those very fine soil particles, like we talked about, and it's generally good at holding water, but poor at holding oxygen. In order to improve that soil structure, we introduce organic material, whether it be a loam material, whether it be compost, leaves. In order to improve the soil, we introduce that by creating larger spaces between the soil particles. These spaces don't hold water well, but they do allow introduction of oxygen to the root zones, which promotes the health of the plant. Soils which have good structure have a balance of small and large spaces between soil particles, and that gives that soil a greater capacity to hold water, nutrients, and oxygen for plant growth. So, why is soil texture and structure important? It determines how water penetrates the soil, determines how much water remains in the soil as well. For instance, when water is applied to the soil, it seeps down through the root zone very gradually. Each layer of soil must be filled to fill capacity before the water descends to the next layer. This water movement is referred to as a wetting front. The water moves downward to a sandy, coarse soil much faster than through a fine textured soil, such as a clay or a silt. For this reason, you may actually have to use a higher volume emitter when we talk a little bit about the drip irrigation. In a sandy soil, while in a clay soil, a smaller emitter may be able to be used to avoid water runoff. So it's important to keep soil moist throughout the entire root zone. If only half of the amount of water required for healthy growth of your garden or landscape is applied at a given time, it's only going to penetrate the top half of the soil, or actually even into the top half of the root zone. The area below that point, where the wetting front stops, remains dry as if no irrigation has happened at all. So the health of your plant depends on that. Adding organic matter to the soil is going to improve the structure, more crumbs or aggregates like we mentioned earlier. This helps sandy soil hold more water and creates large pore spaces in clay soils that improve water drainage. So, how do we irrigate? Here's a couple of ways. You've got a watering can, a bucket, whatever you may have around. You've got a hose as well. Now, watering can or a bucket, that's slow, it's time consuming. It's going to take you time. And where you can be doing other things instead of watering your garden. It takes time. If you've got a creek nearby that you need to water from the creek, if you're watering from a spigot, you may have to carry the water a distance. So it's also like I mentioned, slow and time consuming and can be wasteful. You got a hose, garden hose, and it depends on the size of the garden. It can be very time consuming as well. Also, it's very wasteful since a large amount of the water probably runs off. For instance, try pouring a gallon of water on your garden to see how much is absorbed and how much is run off. So if you irrigate these ways, direct the flow of the water to the soil at the base of your plants. and water slowly so it can penetrate and not run off. Also, don't wet the foliage in the early evening because wet leaves at night can encourage plant diseases. So, we're going to talk about micro irrigation. What is it? It's a slow application of water directly to the plant's root zones. For instance, on the left, if you'll notice, they've got some barrels back there. And it demonstrates how those barrels are used to provide water to the micro irrigation system. For instance, the water from the rain barrels could be used to irrigate gardens, while our discussions really won't address the micro irrigation using low pressure or gravity fed. Information is available on those tops. So on the right-hand side, it actually shows drip tubing being used. And if you'll notice, it's got a drip emitter at each of the plants that you see there. But there are advantages and disadvantages. The advantages are it minimizes water loss due to runoff and evaporation by applying water slowly. It makes very efficient use of water by dribbling out in small amounts, such as a half a gallon per hour or 1 gallon per hour. Thus, all the water is absorbed by the soil, eliminating the waste of that precious resource. You have a higher yield of your crop, better quality of your crop, and better uniformity of crop. The production is better because you're providing an optimum moisture level in the soil at all times. And you can simultaneously apply water and fertilizer if desired, because you can buy these, one with a fertilizer injector on there that allows you to be able to put the fertilizer in the water. Also, this is going to minimize diseases spread by wetting foliage. It requires little land leveling because drip irrigation works well on slope gardens. It saves time when an automatic timer is used on a preset schedule. For small gardens, inexpensive containers and soaker hoses can be used to water the soil. We'll talk about that in a minute. Also, the financial investment for a drip system is reasonably small. If you're willing to spend a few hours to plan, assemble, and install the system, savings in water combined with the increased yield and quality of vegetables and flowers more than pays for the cost of the parts to maintain a drip system. But there are those disadvantages. There's potentially a high initial cost for initial small gardens, and this can be overcome by gardeners getting together as a group. Say you got a few gardeners in your neighborhood, and you can get together, you can buy in bulk, and that helps. Those large amounts of time spent initial planning and the installation stages as well as a disadvantage. So let's talk about low-tech micro irrigation. This is simple. Place water holding containers in the ground. That's all they're doing here. You see the water or milk jug on your left. You see a 5-gallon bucket on the right. You can use 2-liter soda bottles, gallon milk jugs, 5-gallon buckets, kitty litter buckets, you name it. You can drill several small holes in the bottom of the container and place it in the ground. Fill with water. Solutions of compost tea, like we talked about earlier in our compost section, or water-soluble fertilizer can be placed in the containers. It's an excellent way to water individual plants like tomatoes, peppers, eggplant once they're established. Root balls of transplants will need to be watered for several weeks until plants are established though. The distance from the container to the plant is dependent on your soil structure, so you'll need to watch that. Water will migrate through the soil, providing moisture to the roots. Another application that's low-tech on row crops and raised bed gardens is soaker hoses. Soaker hoses, they can be snaked through the bed, providing water to crops, plants, and rows. Alternatively, the hose can be cut in lengths and new hose connection added where needed. Although some soaker hoses are going to need some pressure reducers to work properly. Also, you may have an issue where the end that's closest to the spigot may have a higher pressure and more water, whereas the end furthest away from the spigot may have an issue with not having enough water. Also, you may have an issue with the hoses after a year or two starting to break down and start to come apart. So that's something you may want to think about as well. So here is an example using milk jugs on tomato plants and pepper plants. If you'll notice in the left-hand bed, the tomato has 4 milk jugs around it. As the plants get larger, tomatoes require greater amounts of water, approximately 2 inches a week. In the right-hand photo are a couple of peppers. They're surrounded by 2-liter water bottles, 2-liter water bottles. Peppers don't require as much water as tomato, and they tend to have want a hotter, drier condition. The lines at the bottom, the U-shaped lines, are soaker hoses, and they represent about 36 to 40 feet. They're connected to a T at the bottom, and that way both beds can be watered at once. Alternatively, each bed could be watered individually. For some soaker hoses, though, pressure regulators may be needed. However, soaker hoses are not calibrated and must be watched, like I said earlier, to ensure proper watering. While the LowTech solutions can be used in larger gardens, there comes a point in time where the cost of LowTech solution equals or exceeds higher technology alternatives. For instance, soaker hoses can be expensive, costing about $15 for a 50-foot hose. So let's talk about the higher tech solutions. We're talking about drip tube, drip tape. Drip tube comes in 2 types: solid tubing, which you place drip emitters as desired at desired locations, and tubing with emitters pre-installed at desired intervals. For instance, at 6 inches, 9 inches, 12 inches, 18 inches. And that drip tubing comes in several diameters. For longer runs of tubing, you need a larger tubing. And we'll talk a little bit about that later. Drip tube comes in 100, 500, and 1,000 foot rows. A 100-foot roll of half-inch tubing with a PC emitter built in costs around $30, $40, while a 500-foot roll costs about $150. The tubing with closer spacing costs slightly more because there's going to be more emitters. Drip tape tends to be less substantial than drip tube and comes with the emitters spaced at certain predetermined distances. For instance, you can buy it at 4 inches, 6 inches, etc. Drip tape actually costs about $120 for a 6,500 foot roll. Depending on the application, you may, depending on the application, one or the other may be called for. For example, drip tube for a garden, you may have perennial plantings, blueberries, raspberries, because it has a longer life expectancy than drip tape. For annual plantings like direct seeded crops, use the drip tape. For the drip tape has drip openings at 4-inch intervals, which is good for watering closely placed seeds in summer rows. Drip tape's relatively expensive, and a 6,500 foot roll is basically 2 cents a foot. And at the end of the year, you can just throw that away. So approximately 2,000 feet of drip tape is annually going to cost you about $40. So here's some of the major parts of the drip system. You've got your valve, which is where your water comes in and out. You got a backflow preventer. You've got a pressure regulator, filter, tubing adapter. You got your drip tube, and you'll notice that it has 18 inches minimum between the emitters. You've got an end cap on the end as well. And you can search your garden supply stores. There are specialty locations as well that you're able to find these drip systems, and you can even buy them as a kit. We'll discuss that in a little bit. So, major parts of the drip system. You've got your backflow preventer or an anti-siphoning valve. You can buy some of this stuff at a hardware store, but you may even want to look at your specialty locations that specialize in drip systems. That way you can talk to the person who's there, and they'll know exactly how to build your system. So the backflow preventer or anti-siphoning valve, you're looking at $2 to $6. And what they're going to do is that prevents any water that's in the drip system from re-entering the water supply. This is important to keep contaminants such as fertilizer or bacteria from entering the supply. And some municipalities actually, by law, require this. So, also you need a pressure regulator. Most drip systems work best at supply pressures less than 40 to 60 psi. And that's what exists in most homes. Drip tape is usually designed, it's worked best at somewhere between 12 and 15 psi. The drip tube works between pressures of 20 to 30 psi. So you're definitely going to need one of those pressure regulators. And they're cheap, $10 to $12. You may even be able to find one a little cheaper. So you need a screen or a filter as well. Screens and filters remove those small particles which may be present in the supply from entering the irrigation system. The drip systems work because they use small openings and reduce the pressure to limit the amount of water released. So you don't want to get something in your line that could possibly clog up your emitters and stop the water flow. Those filters are fairly inexpensive, $15 to $20. So you've got your major parts of your drip tube system. You got your adapters and connectors, and your header line. For instance, you've got T's, you've got elbows, you've got your connectors. Adapters are used to connect various components of system, and they connect two threaded connections. A threaded connection such as a screen or filter to the header line, which requires a barb or two pieces of tubing. And those connectors are fairly inexpensive, as you can see there. And the connectors are specific to either tape or tubing. Tape connectors have a barb on one end to attach the header line and a compression fitting on the other end to secure the tape. Header line or lay flat tubing usually is 1 inch or larger. It is used to feed the drip tape or the tube which runs through the garden or the landscape. It can be purchased in either low or high pressure versions at a cost between $50 to $80 for about 250 feet. So, other major parts are your emitters, your punchers, your cutters, and your goof plugs. If you mess up, there are plugs, and that's what they're for if you goof. So emitters, they can be built into the drip tubing or placed into blank tubing at desired intervals. Those placed into blank tubing are barbed. They come in all shapes and sizes. For most home gardens, about a ½ gallon per hour or 1 gallon per hour will work best. The emitters come in two types, a pressure compensating and a non-compensating. Pressure compensating emitters deliver the rated water flow regardless of the pressure in the drip tube. The reason this is important is that drip pressure in the tube is reduced by friction between the water and the tube walls as you move further from the header line. You have punches that come in all shapes and sizes. And if you'll notice, the punch there is it's a pro punch. It's about $18. Picture at the bottom of the center is a figure 8 enclosure for drip tubes. You simply place the tube in one hole and bend the tube end over and slip it through the other end. This is going to close the tube off, making it watertight. There are also compression fittings with closed ends, but they're going to be a little bit more expensive. Then there's those goof plugs that you may need. There's also timers, controllers, solenoid valves. You can get as big as you want to, but you can see some of the prices on those. Those are something you may want to look at depending on the size of your garden, how much time you want to spend there, or how much time you don't want to spend there. So you can go with a timer or any of the controllers of the valves. So here are some garden kits, and garden kits are fairly reasonably priced, and they can run anywhere between say $60 and $240. These kits, normally you can see those in garden centers, seed supply companies, and specialized irrigation companies like I talked about earlier. The drip irrigation kits for a small garden, which is about 100 foot of row crops, cost about $60. Pictured there is a home garden drip tape kit, which costs about $240, and it contains enough that will irrigate a half acre of garden and consists of several different things there. It has your flat tube adapter, it has your header line, it has your screen filter, it has your regulator, pressure gauges, it has your irrigation tape. So anything you would need there. It's got the clamps, the punches, and so drip tape kits, they may be handy for something that you might need, and they usually start at about $80 for a basic kit of watering up to 100 square feet. So that may be something you want to look at if you have a small garden. So we're going to talk a little bit about drip irrigation rules. 1, don't exceed your water supply. Limit the water pressure to 12 to 30 psi. Water flow is going to be limited by pipe size. Drip tube size also controls the length of the run. You can't exceed your water supply, like I mentioned earlier. If you only have 100 gallons of water per hour coming from your water supply system, then you cannot design a system or a watering zone that uses 200 gallons water per hour. When your watering needs are greater than your supply, you just break your landscape garden into smaller watering zones in order not to overtax your water supply. If your water supply comes from a municipal water supply, your supply into the house is less limiting than the amount of water you can draw from any outdoor spigot. If you're on a well, your oversupply may be limited by your well, but you could also be restricted by the flow from your outdoor spigot as well. To evaluate the source flow rate, run water full force from the outside faucet and note the number of seconds it takes to fill a bucket of a known size. Calculate the gallons of flow per hour by dividing the bucket size. Do the math on that. For instance, at a bucket size in gallons, divide it by seconds to fill times 3,600 gallons or 3,600 seconds per hour. That's going to give you the flow in gallons per hour. No watering zone should use more than 75% of the water flow from the outdoor spigot. So in other words, if you have an outdoor spigot that supplies 100 gallons per hour, your system should only be sized at a maximum of 75 gallons per hour. Most homes have water pressure between 40 to 60 psi. So this exceeds the water pressure needed for drip irrigation systems. Drip irrigation systems are designed to operate at lower pressures and use pressure regulators to reduce that water pressure to the 12 to 15 psi for drip tape and 10 to 30 psi for tubing. So as drip lines get longer, the pressure in the lines drop because of friction loss between the lines. As a result, you've got to obey that maximum line length, which most manufacturers list. So work with a manufacturer on that. The loss of pressure can also impact the amount of water delivered at the ends of long runs. This is why the PC emitters are used on longer runs of tubing. This is another reason it's good to maybe work with someone who has some knowledge of this. We also have some publications at your local extension offices to be able to give you some ideas. And also these folks that are specialized, that you may buy your irrigation lines from or your kits from, they know what you might need. So getting that planned on paper first, that's going to be the main thing. So tube planning, like I mentioned, lay that garden out on a sheet of paper, plan your zones, flow to any line, zone, or zones. You can't exceed that 75% of your supply. It's limited by tube size and length. Flow to the zones depends on number and size of emitters or length of drip tape. So zone planning is important since each zone must comply with the rules we just discussed. Here's an example of a garden. If you'll notice that they've broken it down into different zones. On the right-hand side in the light blue, they have some blueberry plants. And if you'll notice, it's covered with drip tube. It lasts a little bit longer. They're perennials. They have, in the red area, they have raspberries, and they're using drip tube there as well. If you'll notice in the garden portions, there is drip tape, and there's also some header line. And so they have these split up into zones that work very well for that. So to wrap up things, plan your zones, plan it out on paper. Obey those rules we talked about. If you only have 100 gallons of water coming in from your spigot, make sure your system is built for 75 gallons of water per hour. Also, check the web. There's a lot of resources on the web, and there's some great things that you can find there. Check with your local extension office. We're glad to help you out. We have a lot of publications, and we can definitely pull some information, and we have the specialists to be able to work with you that we can actually reach out to as well. Here's some resources that are available at the University of Kentucky. If you'll check out those resources there, there's a lot of resources on drip irrigation and different gardening resources. But as I said earlier, if you have any questions, feel free to contact your local extension office. We'll be glad to help you out. And we hope that your drip irrigation experience goes well. We wish you well here on your garden season. And for more information on daily Zoom sessions, check out some of the other items that have been posted. And if you have any questions, feel free to give us a call at any of your local county extension offices. Look forward to seeing you later. Have a good day. Bye.